Welcome back to the Chronocosmonomy channel. This is a channel for the real learners. People who want to learn, who want to discover the truth about the universe. And I did a bunch of statements, released them to the public about 3i Atlas. And right now, we're going to depart from that. And we're going to get back into the bigger subjects. And behind me, you can see a map chart. And on there are the TimeSpace Waves. And that is all based upon the findings of my research, where I have discovered the Keyboa Eclipse cycle. And that's very complex. But you can see with the illustration, the diagram, which is called a map chart, there is a simplification of it. And this really depicts time, and there's some data in there of space phenomenon. But I want to describe this on another level, because they are called time-space waves, and the waves are purely graphical on the map chart. They are abstract. So, in other words, they are not literal waves, or waves that can be measured out in the universe by any instrumentation or tool. They're not going to be there as this. This is a graphical representation. It involves mathematics and a lot of other permutation in order to display what it is. And let me get my hair out of the way, because there's more waves behind me in the quite large image that I made. And I hand painted that, by the way. It's all very accurate, but it was hand painted, so it has that look and feel to it. Now, having said that it is not actual waves, they are abstract waves, which happens a lot. And this is a distinction that the beginner doesn't understand. I mean, a wave is not a wave. There's two major kinds of waves that can be called waves. These definitely can be called waves, but they aren't the waves, for example, something you would see on a terrestrial surface, which will be the ocean, and it has waves that you can see, especially near the beach. The waves come in and they crash and they go back out. There's an undertone, then they come back, and there's this circulation. So you're constantly seeing these waves. This is not the type of wave that's visual. So I'm going to conclude that description, and then we're going to go into the counterpart of these waves, which would be literal waves. And that's why it's called time-space waves. Now, I haven't finished my research on that, and I'm stating it hypothetically. It's a very strong theory, or a major theory within chronocosmonomy, that is stating that the Keyboa eclipse cycle on the map chart is parallel, or the counterpart, of the actual wave. That's a time-space wave that travels through the solar system out into the galaxy and the universe. They're not going to look like this, but when these waves shift, there's going to be some type of a shift in the literal wave. So I've really said a lot. This is advanced science, you know, and I hope that you gain at least 1 or 2 points from this. And to me, it's very exciting. And if you want to learn more, you will catch that excitement. More power to you. And I welcome that. And I'm putting this out to the public. This is the type of thing that I've been doing, and 6 years ago, I wasn't sharing this with anybody. So right now, we're at the public launch from this long stage of development. And pardon me, because I'm a little bit stuffed up. There's been this oppressive weather. There's a hurricane storm system, and it's bringing a lot of chill and humidity around. So woe was me, but this happens. I'm used to it. And we are getting into the winter in the northern climes, or the northern latitudes. So I just want to wrap it up because I've said quite a bit right now about the time-space waves. And I mean, I could just give you kind of a more of an attempt at a description of the literal time-space waves. And it has something to do with multiple planes of motion that are not planes of motion in the absolute sense of planes being a totally flat two-dimensional construct. Because actually there is no such thing as a perfect plane. And I don't know if they really emphasize that, but I'm going to say right here and now that that is a super important feature of the plane, that it's actually warped. The plane is purporting to show that surface which any body, a celestial sphere, the sun or the earth or anything else, would be traveling along this plane. The plane only exists as a mathematical construct to be a representation of what's in the reality of space, or I should say of time and space. So it is fairly close to reality, but I'm clarifying that in reality, there is no completely perfect flat plane of a two-dimensional surface. It doesn't exist. It is just something upon which to etch the orbital path. And that's the terminology that I use, orbital path. And in Chronocosmonomy, we also teach that the orbital paths are not ellipses. It's only the ellipse with keeping or being limited to the frame of reference of the geocentric perspective, or heliocentric, which is multicentric but only two. So I add in three, which becomes a part of the three motional principle, which may or may not be a motional law in comparison with the Chronocosmonomy rotational law, which is a law with an equation. We'll get into that in another video, so I don't want to digress away from what we're saying here with the map charts and the time-space waves, which are all a part of the Keyboa eclipse cycle. And so when you look for that literally or physically in time and space, out into the universe, not an abstraction of it, which is a mathematical display of the data. But when you look for it and you want to map it out, not in a map chart, but if you want to have a solar system map, it's going to have to do with all these planes intersecting. And the key is, how are these planes warping, and as they're intersecting each other, what's created is a nodal axis, if you want to call it that. Sometimes they don't like to, oh, it's an axis, it's just a node. Because what's the axis? So the axis is a point where it has a node on the north and a node on the south. So the crossing of the other planet, or it's intersecting from its plane to another plane, creates the node. So, for example, in the three-body problem, the n-body problem is going to be mostly the moon to the earth, or vice versa. And in that, we have to describe with the coordinates as best as we can when the moon goes through its motions and the earth goes through its motions, where do the planes intersect? And you have a node of where that happens. So that's a predictive point. Now, the node always exists because it is an imaginary moving point, that the moon is not always going to be at that point. But when it does meet up with that intersection of planes, then that becomes the actual node. And that's where it crosses from north to south or south to north, if I made myself clear. So the axis would be connecting those two, because on the other side of the orbital path would be when it crosses the node from the opposite, north to south or south to north, as the case may be, respectively. But that will shift. It will not be an axis 180 degrees diagonal on the diameter. It will have shifted. And the nodal axis does precess. And the precession rate is a little bit more than 20 years for those particular two bodies, but it is a three-body problem because it involves the sun. Everything is in relation to the sun, unless you narrow it down. Now, you could do that to just a geocentric perspective and only focus on the Earth and the Moon. You can do that. And in Chronocosmonomy, we have done that exhaustively, and that's how we are searching for the time-space waves. And so, I mean, I want to say that that's some huge discovery, but actually what it is right now is a huge theory in our conglomeration of theories that are interconnected and overlapping. But as far as this one is so major and so compelling, but yet I can't go out on a limb and say, oh, I know because I see them. I am still looking for them, and how that would be the fundamental fact of reality of the entire cosmos. So maybe or maybe not. It's almost more plausible, because it hasn't been disproven. It's more plausible than the string theory. If you remember that the string theory was being researched and trial and error to do the calculations and find out if the universe was composed of these. these strings, subatomic strings. And the verdict seems to have come out against the string theory. Now, don't let me be the one to pass the judgment, because I still tend to be a little bit open-minded. Like, maybe in some way the string theory has something to say about the bigger truth. Maybe it does. Even though they haven't found any evidence and it doesn't really seem to add up and doesn't seem to make sense, but yet we're still saying that dark matter and also dark energy exist. That's because of the mathematical theories. And they don't want to change the mathematical equation. And in order to make those equations work, you have to make up this other, you know. It's almost as risky as, remember the constant? There was the constant, and it ended up, that was a big mistake. It's like you set this constant and it wasn't a constant. It's like, but you have to admit your mistakes. I mean, look, I have made a lot of mistakes, but we're not going to get into that in this lesson. We're going to leave it at that, and hopefully it's been very inspiring, and we're going to test everything out. We're going to do everything that we can, put our minds together. This is now a group project. Thank you very much for joining in.